So here's a new system. We're going to use elimination or addition to solve it. We can see that the format is the same. It's an x term, y term equals some number. X term, y term equals some number. So the format is the same. We don't have to switch the format like we did on that last one. But even before we start choosing which variable to eliminate, what I want to do is see if there's one that's going to be easier than the others. Now in doing so, I see something unique happening. But I can see that negative 18 and 9 should work. Same with negative 6 and 12. And so it doesn't really matter which one I eliminate. They probably are about the same. So on that last problem, I chose to eliminate the y's. This time I will choose to eliminate the x's. I can see that they're already opposites. I got a positive 9, negative 18. So they should eliminate. I just need them to match now. So, and also the other good thing is 18 is a multiple of 9. So I can just take the equation that has the 9x and just multiply it by 2, which is going to force the x's to be opposites. So I'm going to show that. Okay, so I'm not changing the overall value of the equation. I'm just changing the way it looks. But I have to distribute this 2 into all three terms there. So 2 times 9x is 18x. Now before I move forward, again, the 18x was part of the plan because 18x positive is opposite to negative 18x. So when I combine these two, they should eliminate. Next, 2 times negative 6y would be negative 12y. And then 2 times negative 15 would be negative 30. And if you need help with these calculations, please use your calculator. So let's look at, let's copy this other equation now. Negative 18x plus 12y equals positive 30, right? Well, we see these. We are now ready to add them together. So let's do that. The 18x's minus 18x, that zeroes out. That eliminates just as we planned. But then we have negative 12y plus 12y. That's going to be 0y's. And I'm showing the 0y because I would like to see what it's going to equal. Negative 30 plus 30 is also 0. Now let's stop here, okay? Because we don't actually have to do any more. What I find from this is that I got 0y equals 0. As it turns out, and I would ask you really to think about this, is there something you can multiply by 0 to get 0? Now this may take some thought. It may take you some time to remember some of those old rules. But anything multiplied by 0 is 0. So what I've just written there, it's telling us that it doesn't matter what you replace y with, you're always going to get 0. And what we see here is that the statement here tells us that the equation will always be true. That's for any y value, okay? So, since the y values are always going to be true, the corresponding x values will also be true. Now, of course, you'd need them. But this is also telling us then that essentially the two equations, the two original equations, are the same equation, which tells us then that there are infinite solutions. There we go. And that's actually something you may have to remember, okay? So the answer to this one is actually infinite solutions. Okay, and that's all we'd need to say. And why is there infinite solutions? Because if you were to graph these, you would end up with the same line. It's one line that's on top of another. And so remember, the solutions to a system is where the two lines meet, but the two lines would meet everywhere. They have infinite intersections, and so there's just infinite solutions. We don't have to actually find any one specific solution. All we have to say is that there are infinite solutions.